For number 3, we saw this piecewise function and we looked at it a little bit in class. And one way that you can start graphing these piecewise functions is to just kind of focus, and I'm going to write this in yellow. I know it's going to be hard to see, but I want it to be kind of in the background, is to focus on these domain restrictions and where each of these pieces is actually valid. And so one way that you can start is by, when I was first learning how to do this, I always thought this is kind of like making a wall. So I'm going to, and maybe I'm going to try to do like a highlighter, right? So here, right, from x is less than -2. So at -2, that looks a little dark. I wonder if there's a little bit lighter. Yeah, there we go. So let me try this, right? When x is -2, there's my first wall. And then I look here from -2 to 0. So that means this is, I'm going to have another piece, another function there, another piece of the function. Oops, I don't know how that changed. And then I'm going to have another piece from 0 to 3. So I'm going to draw another wall here at x equals 3. And then lastly, I can talk about, oops, maybe, let's see if we can get a really, right? So this is going to be x is less than -2. This is when x is in between 0 and -2. Then I'll write it up here. This is when x is in between 0 and 3. And on this side is going to be x is greater than or equal to 3. So that's going to go forever that way. This one's going to go forever to the left. And then we see this kind of in between parts. And now, once you have those, right, once you can make sense of the domain, the different parts, now we're going to look at the y values. We're going to look at the different lines, and then we're going to see where do those lines go, right? Where we can graph it and think about it as the entire line, but then we're going to see, well, we only need these different parts of the line. And so I'm going to erase this here, and now I'm going to do this first part in purple. So I'm going to look at the line y equals 1/4 x plus 2, but I only want this part of it. So I'm not going to think about that yet. I want to think about this as a line, and how do I graph a line? So I start at the y-intercept here, and now I'm go up 1, right? This is my change in y is the numerator, and then over 4, 1, 2, 3, 4. Change in x is my denominator. I can even go down 1, and then to the left, 1, 2, 3, 4. Likewise down and to the left. And then I can see I have this really, this entire line. But now is when I want to focus on, right, my domain restriction. Do I need that entire line? No, I only want it when x, right, when x is less than -2. So I only want this part starting here. I only want this part of the line. So I can erase all of this. And I can erase my little slope steps. And so now is where you can kind of see how the walls, right, the yellow lines that I drew can help me decide where to draw this line. Additionally, I want us to pay attention to whether now is this endpoint here an open circle or a closed circle. And if we look at our domain, it says x is less than -2. So that means it's this open circle. And so this first part here, it looks just like that. Now I'm going to do the same. I'll use green for the next one. And our next line is y equals -2x plus 1. But now again, we only want it in this space between -2 and 0. And so I can think about graphing this whole line, right? I'm going to start here at 1, and then I'm going to go, if you want to go to the right and down or to the left and up, both of them work. I'm going to take the shortcut and go to the left and up because I know, right, I only want to be in between this space right here because of this domain restriction. So I can now look at the endpoints. I want this one to be an open circle here at when x equals 0, but then I want a closed circle here when x equals -2. And so now I can connect that piece. My last piece, my second piece now is this y equals 6, and I want that between, right, 0 and +3. And so now my y equals 6 is just the horizontal line, right? This is the same as 0x plus 6, meaning, right, we have our slope is 0 or no slope, meaning we have this horizontal line. And if we look at our boundaries, right, 0 is less than x is less than 3, I don't have any equal to's. So both of these endpoints are those open circles. They're both open endpoints. The endpoints are not included. And then last but not least, we'll use red. We have the line y equals x. And why that's important is because we want to see that this is a line. So this, this is the same as 1x plus 0. So my slope is 1, my intercept is 0. So it's this this line that goes 0, 0, 1, 1, 2, 2, 3, 3, right? It's this line that would go forever, -1, 1, -2, 2, -3, 3, -4, 4, right? In forever in both directions. However, right, I know you're saying, don't do all that. You're going to have to erase it, right? We don't need any of this past here, right? This is why I drew this kind of yellow wall, you know, as I called it in the beginning, because I only want it when x is greater than or equal to. So here's equal to 3, I fill in that dot, and I only want it when x is greater than or equal to 3. So it's going to keep going on and on forever in that direction. And so this is that first part of sketching the graph of this line. Sorry, that was a little too sloppy. I'm going to go all the way so I get each of these points. So this is my y equals x. This little part is my y equals 6. This little part is my, let me clear some space here. My y equals -2x plus 1. And then my last little piece over here, right, is my y equals 1/4 x plus 2. And so I want you to see how each of these pieces, actually, right, each of these functions on the left-hand side, yeah, kind of, right, each of these over here on the left are defined, right? This is my y values, what my shape of my graph looks like. And this is where they're defined. This is the x values, right? This is what piece of this line that I'm looking for. And I'll write these so they look nice here. And now if we look at the domain and range, well, I'll put that in black. Our domain, again, is going to be everything all the way across. So for our domain, we're going to look across, right, left and right, like we've been talking about. And what I want you to see is as we go from -infinity over, oh, all of these, right, we see this in the purple line. All of these x values have a y value. But then when we get to x equals -2, in the purple line, it's not filled in, but look, in the green line, it is filled in. So that means those x values are still included, even though it's a different y value. But as we go all the way across, right, and then looking at positive infinity, what I want you to see is that when x equals 0, both of these points, 1, 0, 1 and 0, 6 are that open circle, meaning that 0 is not included. So if we want to write that in set notation, we can write it as, right, the set of all x such that x does not equal 0, or you can write it in our interval notation, meaning negative infinity to 0, again, parentheses, 0 is not included, and then 0 to positive infinity. Because again, at 3, when x equals 3, looking up here, I want you to see that even though there's a closed circle in the blue, the red is filled in. So that means that x value does exist there. So I'm just going to try and get rid of some of that for our. And now, likewise with the range, right? Look up and down, look all the way up. Starting here, right? Because this purple goes all the way to the left, right? That means it's going all the way from negative infinity. And even though, look here at this open circle, there is a close, right? It's the open circle at y equals 1 is defined, right? We have this point here. And so all of that matters for the range or the domain and the range is that across any point in the graph, is there a y, for the range, is there a y value? Obviously for the domain, it's is there an x value? So even though there's not a y value at 0, 1, right? Because of this open circle here, there is a y value here at, right, negative 4, 1. And so that's really important. And so you can see that as you go all the way up, right? Even here, there's this gap between 5 and 6. But if we look across, oh, but that gap is filled in by the red line. So our range here is actually negative infinity all the way to positive infinity. And lastly, our intervals, we have increasing on, decreasing on, and constant. Now is where we can either, you can look at the individual pieces. So increasing means we have that positive slope. So you can look at the equations, right? Which ones have that positive slope? And so we can see that from negative infinity all the way to 2. And again, right, when y equals x, that's a positive 1 there. And from 3 to positive infinity. And even though, right, the endpoint is included here, when it's an interval, it's not included in the interval, right? It's not increasing at that point, it's increasing after that point. And then constant is just the 0 to 3, right? Our blue line, just the one horizontal line. Oh, sorry, I read the bottom one. Is 0 to 3, and our decreasing then is the green line, right? The only one with the negative slope. So that's from -2 to 0.